The sun, a giant ball of burning gas, provides light and energy to our solar system. It is the heart of our planetary neighborhood, a glowing beacon in the vastness of space. It gives warmth to our planet, making life possible. Without the sun, Earth would be a frozen, lifeless rock drifting through the cosmos. But have you ever wondered where it came from? How did this magnificent star come into being, shining so brightly in our sky? The story of the sun's birth is a tale of cosmic proportions. It all began millions of years ago with a giant cloud of gas and dust called a nebula. These nebulas are like cosmic nurseries where stars are born. Within these vast clouds, gravity pulls particles together, causing them to clump and form new stars. Imagine a cloud so vast, it stretches across trillions of miles, filled with tiny particles like hydrogen and helium. Over time, these particles collide and stick together, growing larger and hotter. As the cloud contracts under its own gravity, the temperature and pressure at its core increase, eventually igniting nuclear fusion. This process transforms the cloud into a shining star, a new sun, ready to light up the universe. Over time, gravity, the force that makes objects fall to the ground, starts to pull the particles in the nebula towards each other. This process is slow, but relentless, as gravity never stops working. The particles, which were once spread out over vast distances, begin to move closer and closer together, drawn by the invisible hand of gravity. As more and more particles come together, the nebula starts to shrink and spin. This spinning motion is a result of the conservation of angular momentum. Just like an ice skater spins faster when they pull their arms in, the nebula's rotation speeds up as it contracts. The once slow and gentle spin becomes faster and more pronounced. Like a spinning figure skater pulling their arms in, the nebula spins faster as it gets smaller. This increase in speed causes the nebula to flatten out into a disc shape. The material in the nebula is now moving at incredible speeds, creating a dynamic and energetic environment. As the cloud collapses, the center gets incredibly hot and dense. The temperature in the core rises dramatically, reaching millions of degrees. This intense heat is a result of the gravitational energy being converted into thermal energy. The core becomes a furnace where nuclear reactions will soon begin. Think of squeezing a balloon. The pressure builds in the center. In the same way, the pressure in the core of the nebula increases as more material is pulled in by gravity. This pressure is what will eventually ignite nuclear fusion, the process that powers stars. This central region of the collapsing nebula is where our sun will eventually form. Over millions of years, the core will continue to heat up and compress until it reaches the conditions necessary for nuclear fusion. This marks the birth of a new star, a process that has been happening in our universe for billions of years. Millions of years pass and the center of the collapsing nebula gets hotter and denser. The heat is so intense that the hydrogen atoms, the simplest elements in the universe, begin to merge. This process, called nuclear fusion, releases tremendous amounts of energy. This hot, dense core, powered by nuclear fusion, is called a protostar. It's not quite a star yet, but it's well on its way. The protostar continues to gather material from the surrounding nebula, growing larger and hotter. As the protostar grows, the pressure and temperature at its core continue to rise. This process is driven by the gravitational forces pulling the gas and dust inward, causing the core to become increasingly hot and dense. Over millions of years, the protostar continues to accumulate mass, and the conditions at its core become extreme. Eventually, the core becomes so hot and dense that nuclear fusion ignites on a massive scale. This fusion process involves hydrogen atoms colliding and fusing together to form helium, a reaction that releases an enormous amount of energy. Hydrogen atoms fuse together to form helium, releasing an incredible amount of energy in the process. This energy radiates outward, counteracting the gravitational forces and stabilizing the star. At this moment, the protostar becomes a star, our very own sun. The birth of the sun marks the beginning of a new era in the solar system, as it starts to shine brightly and influence its surroundings. The sun then enters a long, stable period where it continues to fuse hydrogen into helium in its core, releasing the energy that sustains life on Earth. This stable phase, known as the main sequence, will last for billions of years, providing a consistent source of light and heat to our planet.